You checked the weather yesterday. It says sunshine. Today, it says rain. It feels like the forecast was wrong. But most of the time, it was not wrong. It was updated. A forecast is not a fixed promise. It is the best estimate based on the data available at that moment. As time passes, new information arrives. When new data shows something different, the forecast changes. That change is not a mistake. It is an improvement. To understand why forecasts shift, we need to understand how the atmosphere behaves and how forecasting systems respond. The atmosphere is complex. Small changes can grow into big differences. A tiny shift in wind direction can move a storm slightly east or west. A small increase in moisture can make rain stronger than expected. These small changes are hard to detect far in advance. Early forecasts are based on the best data available, but they cannot capture every tiny detail. As weather systems get closer, those small differences matter more. The closer the event, the clearer the picture becomes. Forecast changes happen because weather itself is constantly changing. Weather data never stops flowing. Radar scans update every few minutes. Satellites send new images regularly. Weather stations report fresh measurements. Weather balloons rise twice a day. Aircraft collect temperature readings in flight. All of this data feeds into forecasting systems. If new data shows storms growing faster than expected, the forecast adjusts. If storms weaken or shift direction, the forecast adjusts again. Forecasts improve because they are constantly refreshed with real information. Weather models are not run once. They are run repeatedly. Each time new data arrives, the model starts again with updated conditions. The new run may produce a slightly different result. As the weather event gets closer, models often increase in detail. They focus on smaller areas with higher precision. Earlier forecasts give a broad view. Later forecasts give sharper detail. When model results change, the forecast changes too. This is not uncertainty growing. It is clarity improving. Local features can change weather in small ways. Hills can shift wind direction. Coastlines can create sea breezes. Cities can trap heat. These effects are difficult to measure far in advance. As a storm approaches, these local influences become clearer. A storm may shift slightly because of terrain. That small shift can mean rain for one area and dry skies just a few kilometers away. Forecast updates often reflect these local adjustments. Forecasts are not published automatically. Meteorologists review model results carefully. They compare different model runs. They study radar images. They check real-time observations. If models disagree, forecasters use experience to decide which outcome is more likely. As conditions evolve, they refine the forecast. Human judgment adds context that computers alone cannot provide. Forecast updates often reflect this careful review process. Technology calculates. Humans interpret. Forecast accuracy improves as the event gets closer. Why? Because uncertainty shrinks. More data becomes available. Models become more detailed. Storm movement becomes clearer. A forecast 5 days ahead contains more uncertainty than a forecast 5 hours ahead. Last-minute changes usually mean the forecast is becoming more accurate, not less reliable. Updates are a normal part of modern weather prediction. Forecasts change because the atmosphere changes. They also change because new data improves understanding. Weather prediction is a living system. It updates constantly. The next time you see a forecast shift, remember, it is refining itself. In the final episode of this series, we will explore how weather apps bring satellites, radar, models, and human analysis together. Thanks for watching. If you enjoyed this video, please subscribe to the channel. You can also follow us on the platforms on screen for more simple, easy to understand videos about the technology behind everyday products and systems.